Welcome to the channel Understanding.Concepts.Of.Physics. We have been doing thermodynamics since past few videos. We are going to continue that for a few more. We are about to end the topic on thermodynamics. We are at the second law of thermodynamics, and today is going to be a very short video. It's just a basic explanation of what second law of thermodynamics is. So as you can see on the screen, there are two definitions which I have written for the second law of thermodynamics. And the first statement says that mechanical work can be completely converted to heat, but heat cannot be completely converted into mechanical work, not the other way around. So work can be converted into heat completely, but heat cannot be completely converted into mechanical work. A part of that can be converted into mechanical work, but not all. This is one of the statements. We'll come to understanding this, and there is another statement that heat cannot flow from the colder region to the hotter region without doing work. So if you have seen my topics on kinetic theory of gases, I have told you that heat can flow from higher temperature region to lower temperature region freely, but heat can also flow from lower temperature region to higher temperature region. But the thing is that here you will have to do work. Without work, you will not be able to flow heat from lower temperature region to a higher temperature region. That's what the second law of thermodynamics is. Now let's just quickly understand how mechanical work can be completely converted to heat. So initially I have a massless frictionless piston with a cylinder which is fitted with a piston, and there is some gas inside this. So you can just see that there is some gas inside this. This is the piston which is free to move in this vertical side. Now let's say if I push the piston down somewhat like this, I'll just move this piston down. Like now the piston is moving down. Now when the piston is moving down, what is going to happen is the volume is going to reduce. As volume is going to reduce, the pressure is going to increase, and as the pressure is going to increase, the molecules will now start to move very faster because they have gained momentum from the motion of this piston. Now what's going to happen is the temperature of this gas will increase, so the temperature would also increase. Now as the temperature would increase, heat is going to get dissipated into the surrounding by the walls of the container. Now however insulated the container you can take, but still there will be some loss of heat. Perfect isolation is not possible, so heat is going to get lost from the container. Now what we have done is we have moved the piston. That means we have done mechanical work, and we are getting converted into heat. Now if you see, after a long period of time, you will find out that the system is going to come into equilibrium. So this system is going to come into equilibrium. As the system is going to come equilibrium, all the energy gained by the molecules will be lost to the surrounding. That means all the work done which we did is now totally converted into work done. All the work done we did, that is completely converted into heat. Now let's take the other way around. Let's try to heat it, and let's see how it is going to get converted into mechanical work. So I have this again same piston. I am keeping it as it is. Now I am going to heat this container. So this is a burner. And burner is going to increase the temperature of this gas. As the temperature increases, the molecules will start moving rapidly. They will collide with the walls of the piston as well, and the piston is going to move up. So I'll just show you how it is going to move up. So the piston is now somewhere around here. Of course the molecules will have more space to run away, so there will be molecules here as well. The density would decrease as the volume has increased. Now if you see when you heat it, the temperature increased, work is also done, but as you increase the temperature, the heat is going to get lost from the surrounding with the walls of the container. As the temperature of the container is higher, temperature of the surrounding is lower, so heat is gonna loss with the surrounding. So whatever heat energy which the burner is providing, some energy is going in doing work, but there will be some energy which is going to get lost. So you will not be able to convert heat completely into work done. There will always be loss of energy. However insulated material you can take this, try to protect that heat should not be lost, but there will be some energy which is going to get lost. So the statement says that mechanical work can be converted into heat completely, but heat cannot be completely converted into work, and there will be some loss. And there is another this statement: heat cannot flow from the colder region to the hotter region without doing work. Now this is a very perfect example of an AC or a refrigerator. So let's say if this is an AC indoor unit, indoor, and this is an outdoor unit, outdoor unit. Oh my goodness. Let's say okay, we have this is an indoor unit, and we have this as outdoor unit, outdoor unit. Now indoor unit and outdoor unit are connected through pipes, through copper pipes, and we can discuss all those. Why does copper pipe? Why is it capped? All those stuffs in different video. But here what I would want to highlight is the indoor unit blows air from the bottom of the bottommost portion of the air conditioner or a refrigerator as well. Now there is a gas or a coolant or a refrigerant we call that is placed inside the pipes of the indoor unit. Now as the warm air is blown over the pipes, the air becomes cooler and the gas becomes hotter. Now this air has to be cooled again. So this liquid, this coolant, is pulled through a motor in the outdoor unit where you have something called as compressor. And this compressor, using the differences in pressures and volumes, this compressor cools the gas again and sends the gas again to the indoor unit. And this way the cycle keeps on going, and the warm air again blows over the cold pipes and we feel continuously cooler. Then the gas is again heated up, and the gas again goes to the outdoor unit and cools it again and comes back into the indoor unit, and it keeps on doing so. So you see, whenever you wish to heat cannot be heat cannot flow from a colder region. So this is a colder region, which is the inside part of the room. Heat cannot flow from the colder part to the outdoor part, the hotter part, without doing work. So if the compressor is faulty, if the compressor is not working, we normally say that the gas is run out. So if the gas is not present in the pipes of the air conditioner, or if the compressor is not working, the room is not going to get cooled. So heat cannot flow from the colder region to the hotter region without doing work. So without work you won't be able to cool it. So that's what the second statement of the second law of thermodynamics is. So this is all about second law of thermodynamics. Hope you have watched my whole video. Subscribe the channel in case you haven't done so, and keep following the videos from the playlist, as all the videos are getting linked. So thank you so much for watching. Bye.